All right, welcome back to the deep dive.
Good to be here.
We are diving into something truly mind-bending today, I think, pulled from the incredible source material you shared with us.
Yeah, these excerpts from The Chemical Loop, Awakens, the Belousov-Zhabotinsky revelation.
Exactly.
And what a revelation it seems to be. This isn't just about some weird chemical experiment.
No.
It feels like a deep dive into a phenomenon that, well, it really shook up traditional science.
Right.
And according to your source, it might just show us something pretty fundamental about how the universe works.
That's really the mission today, isn't it? To unpack these readings, understand this fascinating oddity, the Belousov-Zhabotinsky reaction.
Or BZ reaction, for sure.
BZ reaction, yeah. See why it baffled scientists for so long and then explore these, well, surprisingly cosmic implications that the source hints at.
Mm-hmm. And the core idea, it seems, isn't just about chemicals bumping into each other in the usual way.
No, it's more profound.
It's about motion itself.
Ah.
Like motion wanting to loop, wanting to create patterns.
Mm-hmm. Okay, so let's start maybe with the history, because it sounds like this discovery wasn't exactly welcomed.
Oh, not at all. Far from it. So back in the 1950s, you have this Russian scientist, Boris Belousov.
Okay.
And he's doing research trying to mimic biological processes chemically, specifically parts of metabolism, like the Krebs cycle.
Ah, trying to see how lifelike chemistry might work in a test tube, basically.
Exactly, setting up these chemical analogs.
And based on the chemistry rules of the time, what should he have seen? What was the expectation?
Well, the expectation was stability.
Yeah.
You know, the second law of thermodynamics, entropy.
Things run down.
Right. Everything points towards systems reaching equilibrium. They should settle into a kind of static, predictable state. The reactions happen, and then they find a balance and stop changing much.
Motion should eventually cease, in a visible sense.
Pretty much, yeah, a flat line.
But that is absolutely not what Belousov observed.
Not even close. What he actually saw was, well, kind of the opposite of stabilization.
Oh.
The solution didn't settle down. It pulsed, visibly.
Pulsed.
Yeah, changed color back and forth in a
Yeah.
regular rhythm. And it created these waves, patterns moving through the liquid.
Ooh.
Spirals, concentric rings, dynamic, structured, rhythmic motion just appearing on its own.
Which I imagine must have seemed completely impossible based on the science of the day.
Utterly impossible. He tried to publish his findings naturally.
Yeah.
Rejected, flat out, multiple times. Reviewers basically told him this has to be an error.
Just couldn't be right.
Nope, contamination.
Yeah.
Bad measurements. You messed up.
Yeah.
It was dismissed as, well, chemically impossible.
Because it just flew in the face of that fundamental expectation, decay towards equilibrium.
Precisely. This thing was creating order. It was creating rhythm all by itself instead of just descending into that predictable, stable mush.
Wow. It really shows how resistant scientific paradigms can be sometimes.
Definitely. And it took years, actually, until another scientist, Anatol Zhabotinsky, came along. He picked up Belousov's work, refined the experimental conditions, tweaked the recipe a bit.
Made it more reliable.
Exactly. More reproducible. And only then, really, did the scientific community start to grudgingly admit, okay, maybe something genuinely new is happening here.
But even then, it must have taken time to figure out what exactly.
Oh, absolutely. It wasn't immediate understanding. So maybe let's paint a picture of what this actually looks like.
Yeah, let's visualize it. Your source describes a closed chemical system.
Right, like a petri dish or a beaker.
And the key thing is there's no external meddling, right? No stirring, no pump.
No outside rhythm being imposed. That's crucial. You just mix specific chemicals together.
And the main ones mentioned in your reading?
The core players are things like malonic acid and cerium ions. It's a specific cocktail of reactants, catalysts.
Got it.
In an acidic solution, usually involving bromate ions too.
And when you mix this magic cocktail in, say, a petri dish,
you see these incredible visible patterns emerge, like spiraling wavefronts rotating outwards from a central point.
Wow. Or concentric rings radiating outwards like ripples on a pond, but chemical ripples. And the color changes too.
The whole solution cycles through colors, often red and blue, back and forth, tracing these moving patterns. It's not just chemistry happening, it's visible motion structuring itself.
Okay, so when science finally had to grapple with this and give it a name,
they called it a nonlinear chemical oscillator.
Nonlinear chemical oscillator.
Which, it acknowledges the back and forth, the oscillation, but it still frames it mainly as a chemical thing.
Right. A property of the chemicals involved.
But your source, the one we're looking at, offers a really different label, doesn't it?
Yeah, it calls it a self-resolving motion loop field.
See? That phrase alone signals something different. It's not just about the chemicals anymore.
It's about motion and loops.
Exactly. And that shift in perspective is key to understanding why legacy science, as the source calls it, struggled so much with this.
Because traditional chemistry is built on that idea of going downhill.
Yeah.
Energetically.
Largely, yes. Reactions proceed toward lower energy states, toward stability, toward the end of directed motion. Entropy increasing.
And the B is E reaction just refused to play by those rules.
It fundamentally challenged them.
Yeah.
Because it structures itself. It actively creates and maintains complex, dynamic order instead of just running down.
So that standard scientific description, nonlinear dynamics creates spontaneous oscillations in far from equilibrium systems.
Well, mathematically accurate.
Yeah.
Your source offers a rather blunt translation.
Which is?
Basically. We don't really know why it does this, but we've mapped the math.
Oh, okay.
It captures the effect,
Yeah.
the behavior, the equations. But it's struggled to give a simple, intuitive reason for this persistent, self-organizing motion within that old framework.
And this is where the motion theory perspective from your source comes in. It offers a completely different way of looking at it.
Totally different lens. It doesn't see the BZ reaction as just a chemical weirdo that needs complex math to pin down.
It sees it as what?
As a direct demonstration, proof almost, of what happens when motion is allowed to recursively resolve itself with feedback.
Recursively resolve with feedback. Okay, unpack that a bit.
So it shifts the focus from what the chemicals are doing, chemically speaking,
to how their states are changing.
Right.
And influencing each other over time.
Exactly. How the motion is behaving. The source breaks it down like this. Each molecule involved isn't just doing a one-way reaction. It's entering a looped redox cycle.
Redox cycle. Gaining and losing electrons.
Right. Think of it as a repeating process. The molecule cycles between different chemical states back and forth like a little chemical engine, a loop.
Okay, a loop of transformation. Got it.
And crucially, built into this loop are inherent timing delays.
Delays.
Yeah. Things don't happen instantly. There's a tiny delay in the chemical transformation and a delay in how that change affects its neighbors. That delay in the feedback loop is absolutely critical.
So the state of one molecule after a tiny pause influences its neighbors.
Which then influences their neighbors.
And that influence spreads outwards.
Precisely. It's local motion feedback propagating. It's not like there's a central conductor telling everything what to do.
It's bottom up.
Very much so.
Yeah.
Local interaction spreading and, importantly, syncing up. And what emerges from all these spreading local feedbacks isn't just random noise or chaos. It's sync propagation, a ripple, a coherent wave of synchronized motion moving through the whole system.
Wow. Okay. So instead of just describing chemicals reacting, this view sees the BZ reaction as a temporal rhythm loop.
Yes. A pattern in time.
Expressing itself using the chemicals as its medium.
Exactly. The chemicals are the stage, but the play is this unfolding temporal rhythm. The motion is the star.
And the source emphasizes these aren't just any old oscillations like you'd see on an oscilloscope.
Right. It calls them recursive sync domains.
Recursive sync domains. That sounds complex.
It just means areas where the motion is literally looping back on itself. That's the recursive part. And synchronizing with the motion in the areas next to it.
Ah. Okay. The looping and the syncing together.
Yes. And that creates these incredibly stable, repeating patterns in both space and time. The spirals, the rings, the color changes you can actually see.
Okay. That makes the new terminology a bit clearer. But let's step back again. Why does your source claim this reaction, which sounds kind of obscure, honestly? Why does it claim it could change everything?
Yeah, it's a big claim.
What makes it so revolutionary from this motion theory perspective?
Because, according to the source, it provides real, tangible proof for some pretty big ideas. Ideas that challenge core assumptions in, well, lots of fields.
Like what? What proofs does it offer?
Okay, first, it shows that structure-complex dynamic patterns can self-assemble.
Just emerge on its own.
Purely through motion and feedback loops.
Right.
It doesn't need a pre-existing blueprint or, some kind of external designer.
So structure from dynamics.
Right.
Okay. What else?
Second, it clearly shows how simple feedback loops, with those little time delays, naturally give rise to rhythms.
The oscillations aren't mysterious.
They're an emergent property. They come from the system folding back on itself in time. It's baked into the loop dynamics.
Okay, and there was a third proof.
Yeah, and this one's maybe the most surprising. It shows that even chaotic systems, because the BZ reaction can behave chaotically under certain conditions.
Right.
Even those systems can find stability and order through internal sync.
So the synchronization itself brings order out of potential chaos.
That's the idea. The very act of the motion coordinating brings coherence.
Mm.
And this is critical. The source really stresses that none of this needs consciousness or intelligence or intention.
It just happens.
It just requires motion with memory.
Motion with memory. What does that mean exactly?
It's the idea that the state of the system, the outcome of a chemical step in the loop right now, is influenced by its recent past state within that loop.
Ah, the loop remembers where it just was, in a sense.
In a way, yes. That memory allows the patterns to persist, to influence the future states, and that's what allows the propagation and the stability of the patterns. The past informs the next step.
Got it. Creating a kind of history that builds the pattern.
Precisely. And this is where your source suggests things get really interesting, where fields like biology, cosmology, chemistry, they might start to converge.
Because this principle isn't just chemistry.
It's potentially much more fundamental and applicable across different scales and systems.
Which leads right into the source's really ambitious claim that this principle we see in a petri dish, it's everywhere.
That's the big leap, yeah. It argues the BZ reaction isn't some isolated chemical freak show.
It's a universal principle made visible.
The universally expressed principle. That's the argument.
Okay, so what examples does the source give to back that up? It's a huge claim.
It is. Well, it points to galaxies,
Yeah.
spiral galaxies,
Okay.
arguing that the spiral shape isn't just about gravity pulling things in. It could also be a macroscopic example of nested sink collapse.
Nested sink collapse, like dynamic motion and feedback loops on a galactic scale driving that shape.
That's the suggestion. A kind of cosmic BZ wave writ large, maybe.
Wow. Okay. What else?
It mentions neurons firing in the brain,
Ah, brain waves.
which also propagate in wavefronts, don't they? Patterns remarkably similar visually to the spirals and rings in the BZ dish.
Yeah, you can see the resemblance in diagrams.
The pattern of activity isn't just random zaps. It's often synchronized waves of electrochemical change moving across the cortex.
Okay, that's compelling. And even planetary orbits, those seem so fixed.
Exactly. Even something that looks permanent. The source suggests thinking of them not as static paths dictated solely by gravity,
But as
stabilized loops of motion, patterns where any sync drift or wobble has been damped down and reinforced over billions of years, settling into these stable rhythmic orbits.
So the argument is, from the chemical pulses in a beaker to the electrical storms in our heads to the shape of entire galaxies,
We could be seeing the same fundamental process at work.
motion resolving into pattern through loops and synchronization.
That is the profound claim your source material is putting forward, that the BZ reaction is a little window, a visible, accessible demonstration of this potentially universal principle.
So let's circle back then. We started this deep dive with Boris Belousov, right? Being told his experiment was just wrong.
Yep. Dismissed, impossible chemistry, didn't fit the rules.
And we've journeyed to seeing this Belousov-Zhabotinsky reaction as maybe revealing a deep truth about reality itself.
It's like watching motion resolve into rhythm right there in front of you. It reframes chemistry,
How so?
not just as static elements and equations, but as motion in disguise, motion that's relentlessly seeking pattern, finding it through these loops.
Belousov might have thought he'd somehow broken chemistry.
He probably did. Challenged its limits anyway. But as Zhabotinsky's work showed, and then this interpretation suggests, maybe he didn't break the rules.
Maybe he just found a deeper rule.
Helped crack open a window onto a more fundamental language, a language that chemistry, and maybe the whole universe actually, speaks.
And your sources, the readings you provided, really brought that idea to life, this concept that pattern isn't always imposed from the outside.
But it emerges from within. Through motion, looping back on itself. Through sync.
It definitely leaves you with a powerful thought. Almost unsettling, like you said, directly from the source, for you, the listener, to mull over.
Yeah.
You just watch the universe show you how motion becomes pattern, no particles needed in the explanation, no magic, just loops.
The loop awakens.
Welcome to synchronized chemistry.
Something to definitely think about next time you see a spiral pattern, or a ripple, or any rhythm, really, anywhere.
Absolutely. Well, thanks for bringing these sources to us. That was a truly fascinating deep dive.
My pleasure. It's mind-bending stuff.